Before 1989, the digital landscape was a collection of isolated silos. Computer terminals were physically and structurally disconnected from one another. For a researcher trying to share information, the friction was immense. Accessing distinct datasets meant sitting at different terminals, using bespoke, incompatible programs. In March 1989, a CERN scientist named Tim Berners-Lee wrote a proposal to break this bottleneck by developing a distributed hypermedia system. The project was driven by a single conceptual goal: universal readership. To achieve universal readership, the network had to meet one strict requirement. An authorized user must only need one simple program to access data, regardless of the computer they were using or the country they were in. Realizing this vision required two parallel systems: a technical architecture to route the data, and an institutional governance model to prevent that architecture from fracturing. The first step was escaping the sequential, linear organization of standard documents. This was the core function of hypertext. Links allow a user to navigate from a specific point in one document to entirely different graphics or data types stored elsewhere on the network. This schematic breaks down the two engineering axioms that solved the technical half of universal readership. The first is the Uniform Resource Locator, or URL, which serves as the mandatory network-wide addressing scheme behind every link. The engineering requirements for a URL are strict resolvability and long-term persistence. The address must function reliably over time. It also mandates unambiguity, uniqueness, and information hiding, ensuring that data packets resolve to exact single points on the network without exposing the underlying system complexity. To maintain compatibility with existing infrastructure, the URL scheme was designed to be extensible to legacy and future protocols, such as FTP. The second axiom is HTML, or Hypertext Markup Language. This is the baseline format that every client on the web natively understands. HTML dictates logical structure. It defines headers, paragraphs, and relationships, deliberately excluding visual formatting from the core document. By prioritizing logical structure, the same document can be displayed optimally across wildly different hardware platforms through data format negotiation. URLs and HTML provided the technical solution, but their open-source nature created a vulnerability. Without oversight, the system faced catastrophic protocol fragmentation as it scaled. The early World Wide Web system saw a limited release to the high-energy physics community via CERN in January 1991. In April 1993, the organization made a pivotal decision to release the project's source code into the public domain. Growth was immediate. By late 1993, the web scaled to 500 servers and captured 1% of all internet traffic. By the end of 1994, the web reached 10,000 servers, 2,000 commercial entities, and 10 million users. At this scale, a single public domain codebase could no longer manage the conflicting demands of thousands of commercial actors. To address this, Berners-Lee founded the World Wide Web Consortium, or W3C, in 1994, to serve as the definitive home for the web's architecture. The W3C is coordinated across 3 global hosts. The United States node is anchored at MIT. Coordination for Europe is handled by URSUM, while Keio University in Japan serves as the host for the Asian region. This rapid adoption forced the web's technical architecture to mature into a globally governed, decentralized consortium. W3C membership is open to all entities, which brings corporate competitors together into a single collaborative space. This node map illustrates the resulting governance structure. The base layer is the advisory committee, composed of representatives from every member organization. The advisory committee is responsible for assessing and formalizing consensus for major architectural choices across the web. Guidance on strategy, legal matters, and management is provided by the advisory board. The board tracks ongoing issues and resolves structural conflicts between formal advisory committee meetings. Operating alongside them is the Technical Architecture Group, or TAG. TAG's mandate is to resolve deep technical disputes involving general web architecture. They also coordinate developments across different technologies, managing how systems interact, both inside and outside the W3C. At the apex is the core execution layer, the director, the CEO, and the team of paid staff and fellows who provide technical leadership. This interlocking matrix of committees ensures that no single member can unilaterally alter the fundamental protocols of the web. This flowchart illustrates the recommendation track, the formal operational pipeline for creating web standards. Working groups begin the process by drafting initial specifications and guidelines for new technologies. The first formal stage is the working draft, where the specification is exposed to the community for review. If review identifies technical issues, the working group must continuously republish the draft until the document is stable. Once technical requirements are met and wide review is complete, the document advances to a candidate recommendation. The mature document is then submitted back to the advisory committee for final support as a proposed recommendation. Only after receiving the full endorsement of the W3C members and the director does it become a W3C recommendation, the formal global standard. Every official web standard emerges from this pipeline as a product of collective engineering and broad technical consensus. The W3C maintains a foundational mandate to ensure a web for everything by facilitating access across any kind of device. It also works to maintain trust through secure transactions and trusted collaborative developments. The network survives on two pillars: the technical layer of URLs and HTML, and the institutional layer of the W3C. Technical superiority is insufficient to sustain a global network without a formal framework for trust and continuous standardization. The W3C provides the institutional stability required to maintain the integrity of URLs and HTML against the pressure of vendor-specific fragmentation. Building for the modern web requires understanding both the code that powers the network and the standards governance that guarantees its continued operation.